If you were to pour yourself a shot of pure medical grade hand sanitizer and just drink it, you would fully expect a trip to the ER, right? I mean, you'd expect some severe internal damage.
Oh, absolutely. Yeah, it would be catastrophic.
Right. But clinically speaking, if we look at the absolute microscopic level of what happens to your stomach's ecosystem when you sip like a high-end expensive cocktail, the biological reality isn't actually all that different.
It's a harsh comparison, I know, but chemically, it's
Yeah.
entirely accurate. We focus so much on the feeling of having a drink, the relaxation, the social buzz, that we completely gloss over the chemical reality of the substance we are actually ingesting.
Exactly. So welcome to today's deep dive. We are on a mission today to unpack exactly what happens inside your body when you consume alcohol. And we're moving way beyond that obvious, localized idea of just it makes you tipsy. We want to uncover this genuinely fascinating, newly mapped biological chain reaction.
Yeah, it is a massive chain reaction.
It really is. And we're drawing from a huge stack of materials for you today. We've got clinical research from the NIH, global health data from WHO reports, and some incredibly detailed neurobiology transcripts from researchers like Dr. Andrew Huberman and Dr. Sarah Wakeman.
And to sort of organize all this data, we're going to use a specific framework that the medical community calls the gut-liver-brain axis.
The gut-liver-brain axis. I mean, it sounds like some kind of internal superhighway.
That's actually a great way to think of it. Think of it as this continuous communication network. This deep dive is going to give you a shortcut to understanding how deeply interconnected your organs are. We are going to literally trace the journey of a single drink and show you how it triggers a domino effect across all three of these systems.
So it's not just an isolated thing.
Not at all. It's this intricate dance of microbiology, metabolism, and something called neuroimmune signaling.
Okay, well, let's start this journey at ground zero. Because long before alcohol ever reaches your brain to change your mood, it lands in your digestive tract. And reading through these sources, I mean, one thing becomes abundantly clear about what alcohol fundamentally is at a chemical level. It is a sterilizer.
Right. When you think about it, we use alcohol to clean surfaces, to, sterilize medical equipment, eradicate bacteria on our hands. The mechanism there is that alcohol disrupts the lipid membranes, which is like the protective outer layer of bacterial cells. It basically causes them to burst and die.
Wow.
It's highly effective. But the catch is that ethanol doesn't just magically lose that cellular destructive property because you mixed it with, like, tonic water and a lime.
Right, it's still ethanol.
Exactly.
Yeah.
When it reaches your digestive tract, it acts as a completely indiscriminate bacteria killer.
Indiscriminate. I feel like that is the key word here. It doesn't know the difference between the bacteria on a dirty kitchen counter and the vital, healthy bacteria living inside you.
Right, because you have trillions of microbes taking up residence in your gut right now. This is your gut microbiome. And these microbes, they aren't just passive hitchhikers. They are fundamentally essential to your survival.
They're doing heavy lifting.
Oh, absolutely. They extract nutrients from your food, they train your immune system to recognize threats, and they even manufacture the raw materials for your brain to produce positive neurotransmitters like serotonin and dopamine.
So you've got this incredibly delicate, highly functioning ecosystem down there, and then a wave of alcohol just washes over it.
And the fallout is basically a microscopic mass extinction event. A huge portion of those beneficial bacteria are just wiped out on contact.
Okay, I want to make sure I'm visualizing this correctly. So instead of cleaning out the bad stuff, it nukes the good stuff. And in doing so, it essentially punches holes in the protective fence of your stomach.
Punching holes in the fence is actually an incredibly apt way to describe the medical condition known as leaky gut syndrome. The destruction of that microbiome leads to immediate physical damage to the gut lining itself.
Wait, so what exactly is tearing? Because when we say leaky gut, I'm imagining an actual puncture wound, but it's more microscopic than that, right?
Oh, much more microscopic. The lining of your intestines is made up of a single layer of epithelial cells. And these cells are glued together by these proteins called tight junctions.
Tight junctions, okay.
Yeah, and the role of a tight junction is to act as a highly selective filter. It allows digested nutrients to pass into your bloodstream while keeping harmful substances out. But the combination of the dying microbiome and the toxic presence of the alcohol itself weakens those tight junction proteins.
Oh, I see.
Yeah, the glue essentially degrades. The spaces between the cells literally widen.
Which means the fence is down.
Right.
And what was supposed to stay locked in the digestive tract is now just free to roam.
Exactly. And remember that not all bacteria in your gut are beneficial. You always have some harmful bacteria from partially digested food passing through, just waiting to be eliminated.
Right.
Normally, the tight junctions keep them contained. But with leaky gut, those harmful bacteria, specifically these toxic fragments called lipopolysaccharides, they slip right through the widened gaps in the intestinal walls and pass directly into your systemic blood circulation.
So just from step one, the gut, we already have a devastated microbiome and harmful bacterial toxins floating freely in our blood. Naturally, the body's filtration system has to step in to clean up the blood. But the liver isn't just dealing with an escaped bacteria, is it? It's dealing with the alcohol itself. Which brings us to organ number 2 on this axis.
Right, the liver. Your body recognizes ethanol as a priority 1 toxin. It's a poison that must be dismantled immediately. So as the blood circulates from the gut to the liver cells go to work metabolizing it. The goal is to break the ethanol down into a substance the body can either safely process or eliminate.
Wait, I actually need to stop you there because reading the clinical data on this mechanism genuinely confused me.
Oh,
Yeah, if the liver's whole job is to protect us from toxins, why does the research say the liver's natural metabolic process creates a chemical that is actually worse than the alcohol itself?
right.
I mean, that seems like a massive biological design flaw.
It does seem totally counterintuitive, right?
Yeah.
But it's really a bottleneck issue. Here's how the mechanism works. The liver uses a specific enzyme pathway involving this molecule called NAD to strip hydrogen atoms away from the ethanol.
Okay, NAD.
Yeah, think of NAD like chemical scissors. When it cuts up the ethanol, the resulting compound is called acetaldehyde.
And acetaldehyde is the real villain of this story.
Oh, without a doubt. Acetaldehyde is highly toxic. It's a known mutagen, meaning it actively damages DNA, and it's a group 1 carcinogen. It is significantly more destructive to human tissue than the original ethanol.
So the liver's own defense mechanism essentially manufactures a deadlier poison inside your body.
Temporarily, yes. Because the liver's ultimate goal is to use a second set of enzymes to quickly take that highly toxic acetaldehyde and convert it into a third substance called acetate.
And acetate is fine.
Acetate is relatively harmless. The body can actually burn it for fuel. The problem is the bottleneck. The liver can only convert acetaldehyde into acetate so fast.
Oh, I get it. So if you drink faster than your liver can process it, this highly toxic acetaldehyde just builds up and sits there, actively attacking the liver cells.
Exactly. And because the liver cells are taking a severe beating from this accumulated poison, the entire metabolic process becomes highly pro-inflammatory. The liver recognizes it's taking cellular damage and basically hits the internal panic button. It begins aggressively manufacturing and releasing inflammatory cytokines into your bloodstream.
Cytokines. Okay, we hear that word thrown around a lot in health articles, usually right next to things like tumor necrosis, factor alpha, or IL-6, but what does a cytokine actually do in this context? It's not just like an alarm bell, is it?
No, it's an active weapon. A cytokine is a chemical messenger. So when the liver releases IL-6, for example, it travels through the blood, binds to receptors on other cells in the body, and literally changes their genetic expression.
Wow, it changes their expression.
Yes. It forces those cells to initiate an inflammatory response, which means swelling, heat, and a mobilization of immune cells to fight off perceived invaders.
Which actually brings up something I think a lot of people listening can relate to. We've all had that feeling of waking up after a few too many drinks, feeling incredibly physically awful. And not just a headache, but a general full-body malaise, like a weird underlying anxiety, people call it.
Anxiety, yes.
It's just wild to realize that isn't just psychological guilt, you know?
Yeah.
It's literally my liver screaming at the rest of my body through these cytokines, setting off a systemic fire alarm.
That physical malaise is systemic inflammation in action. And remember the compounding effect here. The bloodstream is now carrying the lipopolysaccharides, the bad bacteria that leaked out of your gut, right alongside the heavy-duty inflammatory cytokines pouring out of the liver.
So the blood is now a very hostile environment. And because the circulatory system is continuous, this toxic inflammatory traffic doesn't just stay in your torso, it travels straight up the superhighway to the brain.
And this is where we hit the third organ on the axis. Ordinarily, the brain is heavily protected from fluctuations in the bloodstream by the blood-brain barrier.
Right. You hear the blood-brain barrier described a lot in podcasts as like a highly exclusive bouncer at a club, but the neurobiology transcripts we pulled describe it much more mechanically than that. It's not a guy with a clipboard, it's a physical structure.
Yeah, the bouncer metaphor is a bit too simplified. The blood-brain barrier is actually a microscopic mesh of endothelial cells that line the blood vessels in the brain. And these cells are packed so incredibly tightly together that only very small, specific essential molecules like oxygen or glucose can squeeze through the gaps to reach the brain tissue. It is a highly secure mechanical fortress.
But alcohol, chemically speaking, has VIP access.
Alcohol bypasses the fortress entirely. Because ethanol molecules are extremely small and uniquely both fat-soluble and water-soluble, they don't even need to look for gaps between the cells. They simply dissolve right through the cell membranes themselves, crossing from the blood directly into the brain fluid.
And here is where the biological story takes a turn from just damaging to genuinely bizarre. Because as the alcohol passes through the barrier, it facilitates the entry of those inflammatory markers from the liver and the gut right along with it.
It bridges the gap. The presence of the alcohol and the subsequent breakdown of the blood-brain barrier's integrity allows those cytokines, the chemical distress signals, to enter the brain's environment. And this triggers a process called neuroimmune signaling.
Neuroimmune signaling. So the brain's own immune system starts reacting to the liver's panic. And once this systemic inflammation reaches the brain, it starts messing with the wiring. Specifically, the transcripts note that it alters the balance of our neurotransmitters.
It heavily disrupts it, yes.
Let's talk about GABA and glutamate then, because this explains so much about how drinking actually feels.
All right, so GABA and glutamate are the brain's primary operating levers. GABA is the brake pedal. It slows down neural activity, making you feel relaxed, uninhibited, and calm. Glutamate, on the other hand, is the gas pedal. It is an excitatory neurotransmitter that increases brain activity, making you alert and responsive.
Okay, so when you have that first drink, the alcohol boosts the GABA, you feel relaxed, the brakes are lightly applied.
Correct. But as the alcohol is metabolized and that wave of systemic inflammation from the liver and gut hits the brain via neuroimmune signaling, the brain attempts to compensate for the depressive effects of the alcohol. It suppresses the GABA and causes a massive surge in glutamate.
So it slams on the gas pedal.
It floods the engine. This hyperexcitability is what causes that jittery, anxious, restless feeling as the alcohol wears off. The brain is pushed completely out of its normal homeostasis into a state of severe inflammatory stress.
And the bizarre aha moment from the research, the thing that really blew my mind reading these neurobiology transcripts, is how your behavior changes as a result of this specific inflammation. You'd think that your brain, sensing inflammation, high glutamate, and toxic damage, would make you feel repulsed by alcohol to protect itself.
You would assume so, yes.
Like if you eat bad food and get food poisoning, your brain makes you nauseous at the mere thought of eating that food again.
But alcohol circumvents that protective instinct entirely. The ultimate result of this neuroimmune inflammation is that it actually increases your desire to drink more alcohol.
Why? I mean, how does inflammation make us want the poison that caused the inflammation in the first place?
It comes down to which specific neural circuits are being disrupted. The inflammation heavily impacts the prefrontal cortex, which is the area of the brain responsible for impulse control and decision-making. It quite literally degrades your neurological brakes.
Oh, wow.
Yeah. And at the same time, the brain is experiencing that incredibly uncomfortable glutamate spike. The reward circuitry learns very quickly that the fastest way to temporarily, artificially boost GABA and silence that uncomfortable, anxious noise is to consume more alcohol.
It's a perfect, terrifying biological trap.
It really is.
Think about it. You drink, you nuke the gut microbes. The leaky gut sends harmful bacteria into the blood. The liver scrambles to metabolize the alcohol, creating toxic acetaldehyde, which causes it to panic and send inflammatory cytokines into the blood. The blood delivers all of this straight through the blood-brain barrier. The inflamed brain spikes your glutamate, degrading your impulse control and leaving you with an anxious craving that your brain tells you can only be solved by having another drink.
The substance creates the exact biological conditions required to drive the demand for more of the substance. And the clinical data highlights something crucial here. This cycle isn't just happening to people on week-long benders. Even low to moderate drinking, just a few drinks a week, keeps this inflammatory cycle simmering in the background.
So even if you aren't drinking every day, that wind-end habit leaves you with a constantly disrupted microbiome, higher baseline cortisol levels, and an underlying state of physiological stress that you might not even realize is tied to the alcohol.
It resets your baseline to a state of chronic, low-grade agitation. The alcohol effectively weaponizes the body's own immune and digestive systems to reinforce the habit.
Okay, so having thoroughly mapped out how the gut-liver-brain axis is hijacked, we need to pivot to the actionable takeaways. Because if you're listening to this, you're probably mentally calculating the damage and wondering how on earth you break this biological loop. Can this complex system actually be healed? Or is the fence permanently full of holes once you've caused the damage?
The human body is remarkably resilient. While the systemic damage is significant, the research is definitive. The axis can absolutely be repaired.
That's a relief.
But the first and most necessary step, according to the clinical data, is abstaining from alcohol. You cannot heal a burn while your hand is still on the stove.
Right, you have to stop pouring the hand sanitizer onto the delicate microbial garden.
Precisely. You need to give the brain's neural circuits the space they need to reset. And the neurobiology transcripts provide a very specific timeline for this. It generally takes 2 to 6 months of abstinence for those specific neural circuits, the ones controlling cravings, impulsivity, and the GABA-glutamate balance, to physically rebuild their receptors and return to a normal baseline.
2 to 6 months just to get your baseline back. That is going to be an incredibly tough pill to swallow for someone who just enjoys a couple of beers on the weekend. I mean, that is a long time to wait for your brain to fix itself.
It is a sobering timeline, no pun intended.
Uh,
The reason it takes that long is that the brain physically has to upregulate and downregulate receptors that have been altered by chronic inflammation. It is structural repair, not just a chemical flush.
okay, that makes sense.
However, you don't just have to passively wait for the clock to tick down. The sources provide a highly specific, active dietary intervention to accelerate the healing of this axis.
And it goes right back to ground zero, right? The gut. Because if the gut is leaking, the liver is stressed. If the liver is stressed, the brain is inflamed. So the goal is to rapidly replenish the healthy gut microbiome and patch up those tight junctions in the intestinal wall.
Exactly.
And the clinical recommendation found across these sources is to consume 2 to 4 daily servings of low-sugar fermented foods.
We're looking at foods containing active, live bacterial cultures. Things like kimchi, sauerkraut, natto, or unsweetened kefir. Or, if you absolutely cannot integrate those into your diet, utilizing high-quality, clinically tested probiotics.
But how does eating a side of sauerkraut actually fix a leaky intestine? Are the bacteria acting like little construction workers in there?
It's more about terraforming the environment. When you consume these fermented foods, you aren't just dropping seeds onto barren soil. The lactic acid bacteria in fermented foods actually change the pH of your digestive tract, making it a hospitable environment for your own native beneficial bacteria to rapidly multiply and return to power.
Oh, so it sets the stage.
Right. And as this healthy microbial ecosystem flourishes again, they begin producing short-chain fatty acids, like butyrate.
And butyrate is the fuel that the intestinal cells use to heal.
Exactly. The epithelial cells use that butyrate to repair themselves and to synthesize new proteins, effectively re-gluing those tight junctions. The holes in the fence are patched.
And once the fence is patched, the domino effect runs in reverse. The harmful bacteria start leaking into the blood. The liver isn't dealing with systemic toxins anymore, so it calms down and stops overproducing inflammatory cytokines.
And the stream of neuroimmune inflammation traveling up to the brain simply dries up. The brain is no longer being bombarded by distress signals. The glutamate spikes subside, the GABA levels stabilize, and the prefrontal cortex regains its ability to regulate impulses.
So what does this all mean for you listening right now? It means you aren't stuck with the damage. You have agency here. You can actually start repairing the neural circuits in your brain that dictate your mood and your cravings just by eating a few servings of fermented foods a day to heal the microscopic ecosystem in your stomach.
It completely reframes our understanding of neurological health. We have spent decades treating the brain and the digestive system as completely separate, unrelated entities.
Yeah, we really have.
If you have anxiety, you treat the brain. If you have an upset stomach, you treat the gut. But this data proves they are deeply, intimately connected. Healing the stomach is quite literally a biological prerequisite for healing the brain.
It completely flips the script on how we view alcohol, too. We usually think of it as a localized substance, something that just makes us act a little silly, helps us unwind after a long day, or maybe gives us a headache the next morning. But bringing this deep dive to a close, the sheer staggering interconnectedness of the human body is the real star of the show here.
The journey of a single sip of alcohol is profoundly complex.
It really is. A drink acts as an indiscriminate bacteria killer in the gut, wiping out the microbes that keep you healthy. It forces the liver into a dangerous metabolic bottleneck, creating a highly toxic poison that triggers a desperate inflammatory panic. And that panic travels through your blood, bypassing your brain's security system to literally hijack your regulatory circuits, sparking anxiety and demanding more of the very poison that started the fire.
It's wild when you put it like that.
But amazingly, the simple, intentional act of taking a break and eating fermented foods can patch the damage and turn that entire biological superhighway around.
It serves as a powerful reminder that we are walking ecosystems. Every choice we make cascades through the whole network.
Which brings us back to where we started. We said at the beginning that usually when we think about having a drink, we picture a pretty simple straight line to the brain. But now we know that straight line is a total myth. It's a massive, tangled web of cause and effect starting right in your stomach.
And it forces us to deeply reconsider the influence our digestive tract has over our conscious mind.
Exactly. Which leaves us with this final thought for you to chew on. If the microscopic bacteria in your gut have enough power over your neurochemistry to drive intense, physical cravings for a toxic substance, what other daily behaviors, subtle moods, or unexplained desires are secretly being completely orchestrated by the trillions of microbes living in your digestive tract right now?